Okay, so in the last video, we looked at how to verify this identity by starting with this left side, cotangent of x minus tangent of x, and using that as our given and showing that it was equal to the right side, 2 cosine squared x minus 1 over sine x cosine x. This time, we're going to try it the other direction. So we're going to start with the 2 cosine squared x minus 1 all divided by sine x times cosine x, and we're going to use that as our given information, and then we'll verify to show that it equals cotangent of x minus tangent of x. So the first thing that I'm going to remember is my trig identity hexagon so that I can recall those fundamental trig identities that are super useful. So tangent goes on the left, that's sine divided by cosine, and then the reciprocals, reciprocal of sine is cosecant, reciprocal of tangent is cotangent, reciprocal of cosine is secant, and we put a 1 in the center. So when I remember my triangles here, they remind me of the Pythagorean identities. So sine squared plus cosine squared equals 1. And I've got 2 cosine squared x minus 1. So I'm going to start by using that Pythagorean identity, sine squared plus cosine squared, and replace that with the 1 here in my numerator. So my next step, I will have 2 cosine squared x minus, but instead of that 1, I'm going to use my Pythagorean identity, sine squared x plus cosine squared x, and that's still all divided by sine x cosine x, and my reason for that was substituting a Pythagorean identity. Okay. So next I'm going to go ahead and distribute to get rid of those parentheses and simplify. So I'll have 2 cosine squared x and then minus cosine squared x. That's going to leave 1 cosine squared x in the numerator. And then a minus sine squared x. And that'll be divided by sine of x times cosine of x. And that was the distributive property. And then we simplified. Okay, so next thing we're going to do is, since we have a binomial in the numerator here with that subtraction, we're going to split this into 2 fractions and simplify. So I'm going to put the first term in the numerator, the cosine squared x, over the denominator, sine x times cosine x. And then I'm going to put my second term in its own fraction, sine squared x in the numerator, and that's over that common denominator, sine x cosine x. And that was a strategy for splitting into 2 fractions. Okay, so we decompose those fractions, and now we can simplify. So if we've got a cosine here in the denominator, that will cancel with one of them in the numerator because there's a cosine squared there, so that gets rid of the square. Then in the second fraction, the sine in the denominator will get rid of one of those sines in the numerator. So instead of a sine squared x, we'll just have a sine x in the numerator. And that will leave us with a cosine x over sine x minus sine x over cosine x, and that was simplify. So we simplified those fractions. And then looking at our hexagon for the fundamental trig identities, cosine divided by sine, here's cosine, here's sine, and we would be using a quotient identity then, because remember the next 2 consecutive vertices form a quotient identity on the hexagon. So cotangent is the ratio of cosine divided by sine. So I can use that quotient identity here to change cosine of x over sine of x into cotangent of x. Then when we do that same process with sine divided by cosine, now we're headed the other direction. So tangent is sine divided by cosine. Again, two consecutive vertices form that ratio. So we can change sine of x divided by cosine of x into the tangent of x. And that was applying two quotient identities. And now we can see that we've arrived at our destination, right? We set out with this given information to show that it was going to get us a path all the way to the other side of the equal sign. So we've now shown that 2 cosine squared x minus 1, all divided by sine x cosine x, that does in fact equal cotangent x minus tangent of x. So that now that trig identity is verified.